right? So now, there is this exercise which is here that I left you. I told you to do for me these questions. Next time, I will not admit people who don't do my exercise. So you do the exercise. If I give you the exercise, do it. Which we are going to be referring to this exercise. There are some questions which are there. But for now, you can do all the questions up to number 12. I told you this is A, B, C. So you write number 11, the answer is B. Number 10, the answer is A. Number 9, the answer is D. And you send them to WhatsApp. Is it okay?
Yes.
Good. I like it because you are good listeners. So let us look at photoelectric emission or thermionic emission. Mwesigwa, do you hear me very well? Mwesigwa, are we together? Mwesigwa, unmute. Okay, so photoelectric and thermionic emission. What is photoelectric emission? What is photoelectric emission? So you know that light is a form of radiation. I remember in senior 3, we looked at radiation when we're looking at heat. We say that radiation is the transfer of heat energy from one point to another by means of electromagnetic waves. So it means that normally it is whenever there is heat, there is light, isn't it? Whenever there is heat, there is light. So if the sun is burning, that's why we can have light. Otherwise, if the sun was not burning, we wouldn't see the light. So the light itself is in the form of a radiation, an electromagnetic radiation that is produced by the sun. So when this light is incident on a metal surface, on a specific metal surface, there will be electrons that will be emitted from that metal surface. There will be electrons that will be there will be electrons that will be liberated from that metal surface. Not all metal surfaces, or not all metals, but specific metals. And zinc is one of the metals that can produce or can emit electrons whenever a radiation like light falls on it. It emits electrons. What are electrons? We have seen that electrons, these are the smallest, they are smallest charged particles, small charged particles within the atom of within the atom, and they are moving around the nucleus. They are negatively charged. So whenever a metal is incident on it with light, whenever light is incident on a given metal, zinc as a metal, electrons will be emitted. Electrons will be produced. I don't want you to use the word produced. I want you to use physics terms. So electrons will be emitted from that metal surface. And these electrons are negatively charged. So they are saying that photoelectric emission, members, are we together?
Excuse me, teacher.
Yes.
Excuse me, teacher.
Yes, Patricia.
Teacher, I've just joined. What were you talking about? The topic here.
Today's topic we are looking at thermionic emission. Thermionic emission, and I've just introduced it. You have joined, should I say, on time. So Don't get worried. The previous 15 minutes, I was looking at the where we started last time, okay? But that's
Okay.
thermionic emission. So thermionic emission is the process by which electrons are emitted from a metal surface when that metal surface is heated, we shall produce electrons, or electrons shall be emitted from that metal surface. Now, that is thermionic emission, the process by which electrons are emitted from the metal surface when they are heated. The word thermal means heat, and emission means emitting. Something is emitting. So thermionic, there is heat that is incident, or that is subjected to a metal. And ionic, when you look at ionic in chemistry, I think these must be particles, or something must be charged. So it means that thermionic emission produces charged particles, and these charged particles are electrons, but these electrons are produced whenever a metal is heated. That is thermionic emission. That's thermionic emission. So if I may try to shall we view these two things together, so that you get to know. Let me fixing the camera. So, and the photoelectric emission, sometimes called photoelectric effects, the process whereby electrons are emitted when a radiation falls on a metal surface. So this one, a radiation falls on metal surface and electrons are emitted. That is photoelectric. And then thermionic emission, electrons are emitted when a metal is heated. When a metal is heated. Let me first fix the camera. So trying to fix the camera, just holding it. Okay, so I wanted to give you the difference between these two terminologies. Photoelectric effects, photoelectric effect. Sometimes, yeah, it's called photoelectric effect. You should know that, or they can call it photoelectric. So photoelectric effect is the process by which electrons are emitted from the metal surface when a radiation falls on it, falls on it. That is photoelectric effect. So photoelectric, there is a radiation that is falling on a metal surface, like light is falling on a metal surface, and that metal surface produces electrons. And then thermionic emission. This one is the process by which electrons are emitted from a metal surface when heated. That's what we are talking about, heated. Okay. So that is thermionic emission. There must be heating. There must be heat. Heat that is subjected to a metal, and then the metal becomes hot. Once it becomes hot, it starts to produce starts emitting electrons. That is thermionic emission. Now here they deeply explain photoelectric emission and say that the metal surface, e.g. the zinc plate. So the zinc plate, it is normally used as a cathode. If I say cathode is a negative plate. If you look at a dry cell, the dry cell has got the positive and the negative. So up there, we have the positive, that small cap on the dry cell, it is positive. But the negative is the one which is down. So the negative is what we call the cathode. The negative is called the cathode, right? The cathode is called the cathode. So the cathode is negative. So the zinc plate is normally used as the negative plate because for it, it's good at emitting electrons because of its physical properties. So also the radiation that is falling, when you look at photoelectric emission, where we say that there must be a radiation that falls on the metal for electrons to be emitted. So this means that this radiation is in the form of an electromagnetic radiation. So it must be an electromagnetic radiation that is later on, we shall look at the applications later on. There are very many applications, but we are still in the introduction. So there must be a radiation, and it is form of an electromagnetic radiation. The electromagnetic radiations, they are seven. There are seven electromagnetic radiations, all waves, there are seven. We have the gamma rays. These are radiations in form of electromagnetic waves. So we have gamma rays, we have X-rays. We have also what we call the ultraviolet. We have also another one that we call, we have what we call the visible light. Visible what? Visible light. The one that you see. The light that you see of different colors, red, orange, that is visible light. That one you can see it. Ultraviolet, X-rays, gamma rays, we cannot see them. We cannot see them, but we can feel them. So we have visible light. We have also the infrared. We have infrared. So 1, 2, 3, 4, 5. There are 7. Who can tell me the other two? Who can tell me the other two? Anyone who knows the other two? Let me see, people can do some research. Melvin, do you know the other two? So the other two, we have the microwaves, the ones which are found in your microwave at home, the microwaves, and also we have another one which is called the radio waves, the radio waves. So these are, all these ones here, these ones are what we call the electromagnetic waves. So you look at electromagnetic waves when you are studying waves, but I've just given you that these are radiations that are in form of electromagnetic waves. And when these radiations are incident on the metal surface produces or emits electrons. Now, what you should know is that not all these radiations will produce or will liberate electrons. The reason is that the liberation of electrons depends on the energy, depends on the frequency of that radiation. Depends on the frequency of that radiation. Now, if you don't know what frequency is, let me try to explain to you what frequency is. At home, you have a radio, isn't it? And you know some frequencies for some radio stations. For example, like the one that you like most, let me say, maybe Sunny, 88.2. Members, are we together?
Yes.
Yes, so,
yes, teacher.
So you find that the frequency, for you to get the frequency of that radio, if you pull out your phone and you want to listen to Sunny, you look for the frequency and it will give you 88.2. So down there they put megahertz. These are units. Hertz is the unit of frequency. So it means that Sunny FM is using radio waves. So radio waves are part of the electromagnetic waves, and this is the frequency that will be for that specific radio station. So even the electromagnetic waves that are incident on a metal surface must be having sufficient energy, depending on the frequency, sufficient energy for them to liberate the electrons, for them to emit the electrons from the metal surface. There must be have sufficient energy. With sufficient energy, radiations with sufficient energy are the ones that are able to liberate or emit electrons from the metal surface. So not that if you get your torch and then you make the light incident on a metal surface, you expect electrons to be emitted. No, because that torch is producing light, but the light may not be having sufficient energy to liberate the electrons. So they make the frequency of the radiation to have sufficient energy such that that radiation can emit the
following figure.
Okay, so now it normally occurs in phototubes and photoelectric cells. Now, Maya was asking about the applications of photoelectric. We are looking at photoelectric, not thermionic emission. Let us look at photoelectric. So the applications of photoelectric cells, one of them is photoelectric. One of them is the photoelectric cells. What are photoelectric cells? Photoelectric cells, these are very small cells that are found. They are found in solar panels. Okay. Some of you have calculators that have a solar panel on it. Members, are we together?
Yes, we are together.
So those solar panels, they have what we call photoelectric cells. Whenever you put that calculator in the sunlight, it's going to charge. Whenever we put solar panels in the sunlight, they are going to charge our batteries. How? The process is that there will be electrons that are going to be produced within those photoelectric cells. There will be electrons that will be produced. Inside those photoelectric cells, there are small metals, and once light is incident on those metals inside the photoelectric cells, electrons will be liberated. Whenever electrons are moving from one point to another, current is generated, or let me say electricity is generated. Current starts to flow, electricity starts to flow. So that current that is generated from the photoelectric cell that is found in the solar panel will be stored by the battery of that solar panel, and at night you have light or you have electricity. So inside the solar panels, we have what we call the photoelectric cells. Some of them are found in photo tubes. What are photo tubes? We have seen the fluorescent tubes. You see the fluorescent tubes? Inside the fluorescent tubes that you have at home, those tubes do not have bulbs in them, but they have metals that are producing electrons. They are producing electrons, and it's made in the way that those electrons that are produced are the ones that liberate the light whenever they strike the tube, inside that tube. So the tubes have different colors. Some are green, some are red, some are white. So if the electrons strike the color or the powder inside those tubes, then that powder glows and it produces light. But the main element is that there will be electrons inside them. So photoelectric cells, you have seen, is one of the applications. Photoelectric cells is one of the applications, and we shall see how these photoelectric cells are able to produce electrons. Members, any question?
No.
Cynthia, I want questions.
Over regular pentagon of side 72.
Sandra. Any question, members?
Yes.
Okay. So photoelectric cells or phototubes, how do they work and what are they? So photoelectric cell, in these 4 minutes, they say that photoelectric cell consists of a cathode coated with a photosensitive material and the anode. These are enclosed in a vacuum glass tube. So there is a cathode inside. I told you that a cathode is negative. Its purpose is to produce electrons. And it is coated with a photosensitive material. What's the use of the photosensitive material? The material is sensitive to light, such that if light is incident on it, it is going to produce electrons. So this is what they are talking about. So there is the zinc cathode here. This is the zinc cathode. And inside it is enclosed in a vacuum. So the cathode is here, and it is coated with a photosensitive material. Now inside also the photoelectric cell, there is an anode. Anode, this word anode is the terminal that is positive. So cathode will be negative, and that's why it is connected to the negative. And the anode is positive and it's connected to the positive. In other words, members, this will be like a battery here. So here we have positive. The longer one is positive, and the shorter one is negative. So this is like one dry cell and another dry cell. So they are going to be arranged. So the positive is here, which is long. The negative is the short terminal here. So the cathode is connected to the negative. A is the ammeter. Its purpose is to measure the current that is flowing. So the electromagnetic radiation, maybe from the sun, is incident. You can zoom in very well there and you see the diagram. try to zoom in clearly for you. So an electromagnetic radiation is incident on that zinc cathode. When it is incident on this zinc cathode, which is coated with a photosensitive material, the zinc cathode will start producing electrons. So members, these are electrons. These dashes that you are seeing are electrons. And since our electrons, we say that electrons are negatively charged. The anode is positively charged. So it means that electrons which are negative charge are going to move from the cathode to the anode, because the anode is positively charged and electrons are negative. So the electrons will be attracted to the anode. Are we together? You know, negative and positive, they attract each other. So the electrons which are emitted from the zinc cathode are going to be attracted to the anode. Whenever the electrons are flowing, there will be current that is generated. Are we together?
Yes.
Okay, so in the next session, I'm going to start here again and also write somewhere, show you more explanation of this, and then understand what we call photoelectric effect. So the next session, once this one ends, we go back and start. We shall not have a break. Should we have a break? Members, should we have a break?
Yes.
Okay, a break of 2 minutes. I'll give you 2 minutes and we shall resume after 2 minutes.
Okay.